Okay, pause and copy, pause and copy, pause and copy, pause and copy. All right. We have a farmer who has a barn. And on that barn, there is a wall. So let's do the barn. Here's the barn, a straight line. And then I have a rectangular plot. Let's go like this. Ooh, that's kind of cockeyed, but oh well. Oh, even worse. I think you get the idea. You know what? That is awful. Let's just do a nice, calmly considered rectangle. Okay, that's a bit better. A bit better. Too much coffee. Anyways, rectangle. Let's go with X for this side length, and then we'll go Y over here, and also Y over here. Now we have trying to maximize what? Area. Trying to maximize area. So let's write down an area equation. Area is going to be X times Y. All right. Then what else do we have? We want to come up with a cost equation, okay? So 5,000 is my budget. And that's going to be the money spent on fencing. So how much do we spend on fencing? Well, it's 20 bucks a foot. But one of the walls is shared. So let's say this one here is shared. Okay, so this side length will be multiplied by 20. And this side length will also be multiplied by 20 over here. But my shared side is only multiplied by 10, since me and my buddy are getting together and sharing the cost. So what is the total cost? Well, I add up these three things. I got 10y plus 20x plus 20y. Because it's 20 bucks per foot, and in this case I have y feet. Okay, simplify. Collect like terms. 20x plus 30y. I got some extra zeros there. I'll divide by 10 just to clean this up a little bit. Okay. So I read the equation, I read the question, and I determined that I needed an area equation and a cost equation. Now I'm trying to maximize area. I got too many variables, so I should eliminate one of them. It doesn't matter which one. I'm going to solve for y down here. Plug it in there, and that will take care of one of my variables. Because I want to do a derivative, right? I want to do a derivative here, so I need to have just a single variable. This is single variable calculus. So let's eliminate. So solving for y here, I get 500 minus 2x over 3 is y. And then this quantity will go in for y there. So area is x times this fraction. And what can I do there? I'll multiply that x in. Take the third out. Take the third out. Put the x in. Just to make it a bit easier to do my derivative. Aha! Single variable. Now this is a function. I can find the maximum of this function. I want to maximize my area. So my derivative will be, okay, the third can stay out front. 500x becomes 500, then minus 4x inside. I set my derivative equal to 0 to find my critical numbers. So 500 is going to be 4x. So 125 is x. Now I should check that this does indeed give me a maximum. So I want my original function a, I want to be increasing and then decreasing. So I take some test points, plug them into my derivative. So if I plug in, say, x equals 0 here, I think you'll see I get a positive, so it is increasing here. And if I plug in, like, say 200, which is over here, plug in 200, this will end up being negative, so my derivative is negative. Boom. So this is indeed the max I'm looking for. The question is find the dimensions. So I have the x value, which maybe I'll circle just to make it easier for my grader. And then y was what? 500 minus 2x over 3. Yeah. So plug in my 125. And I get 250 over 3 feet. So I've given the two dimensions, x and y. That is sufficient. Okay, moving on. Next question is, where is it? There it is. Okay, pause and copy. Pause and copy and give this a try if you want. Why don't you just give it a try if you want to. But if not, I will start the solution right now. Two equations. What are the equations? Looks like we have a volume equation. Okay. So volume is 32,000. And I want to minimize material used. So that would be area. Okay, the area. Now, I don't need a top for this box. So I just have 5 sides. Okay, the bottom, the base here, is going to be x times x, right? So that's x squared on the bottom. And then I got the 4 faces. So like this face here would be xy. And there are 4 of those, so I put a 4 there. Okay, so area is x squared for the base, and then the 4 sides of the box. Now, my area is what I want to minimize. I have too many variables, so I should use my volume equation to eliminate a variable. What's the volume of this box? It's going to be, you multiply the 3 dimensions, and you get x squared y. So in principle, you can solve for x or y here, but I think you'll agree, seems easier to solve for y. So I get 32,000 over x squared. Take that, plug it in for y here, hope for the best. I think we're in good shape though. X squared plus 4x okay, 4 times 32. 128. So I get 128. How many zeros? 3 of them. 2, 3. And I get this canceling with my power of 2 there. So just x. All right. I have a single variable. I can take a derivative, set it equals 0. Okay, just to give you the details here, this is 128,000 x to the minus 1. So when you do a derivative, this minus 1 comes down, and it becomes minus 128,000 x to the minus 2. That's what I got here. Set the derivative equal to 0 to find my critical numbers. 2x is 128,000 over x squared. So x cubed is 64,000. Now, you may think you need a calculator, but you do not. 64, that is, well, sorry, it's 64 times 1,000, right? I did that because I know this is a cube, and this is also a cube. 64 is 4 cubed. 1,000 is 10 cubed. So x is going to be just 4 times 10, which is 40. Let's check that that is indeed a minimum as required. So 40. Plugging values into my derivative. So if I take, say, the number 1, x equals 1, plug it in here, I'm going to have 2 minus 128,000, which is quite negative. And if I plug in like something over here, how about a billion? Plug in a billion. You're going to get big number minus small number positive. Okay, so I do have a min as required. So x equals 40 will minimize this, and I should find the corresponding y. What was y? Y was 32,000 over x squared. So y is 32,000 over 40 squared. So I'll use factoring again to sort this out. Okay, 32. 32, 32, 32. That's, oh la la, qu'est-ce qui se passe? No, no, no. Okay. All right, we're trying to do this without a calculator. Fancy footwork. 32, that's power of 5. Power of 2, rather. 2 to the power of 5 times 1,000. So this is my 32,000. On the bottom, I have 2 squared times 10, all squared. So this factoring is going to make it a lot easier to cancel all the nonsense here. So I get 2 to the 4 dot 100. So what does that give me? 2 times 10. This cancels this. The 100 kills my zeros here. So 20 is my y. Units, what are the units? Can't remember. Meters, feet, who cares? We are mathematicians, we don't care about units. centimeters. Centimeters. So, just for fun, put the centimeters in here. X equals 40 centimeters. Circle it so my grader is a happy camper. Et voilà.